Hello, trigonometry. For this first video, we are going to be simplifying trigonometric expressions using the fundamental and Pythagorean identities. Now, this lesson is a building block to the goal, which is verifying identities, and you'll see that in the next video lesson. At the top of the notes, you can see the fundamental identities that I need you to be familiar with and that we will be referencing. These identities are provided to you on your formula sheet that we will continue using. I will send out an updated PDF of that sheet to you through Canvas. So with identities and simplifying expressions, we're basically looking to replace terms or factors with alternatives that allow us to simplify. Let's take a look at example 1. We've got cosine theta times sine theta times tangent theta. And so in general, as a default, we're going to try to get things in terms of sine and cosine. And that will allow us to find like terms or common factors that can be canceled. Here, we'll leave the cosine and the sine. And we'll replace tangent with sine divided by cosine. So in this case, we've got a times cosine and a divide by cosine, and we can actually cancel these terms, or these factors, out of the expression. That leaves us with sine theta times sine theta, or in simplest terms, sine squared theta. And so that's what we're looking for when we're simplifying trig expressions. Now, with this, you won't ever know if you've truly fully simplified. So think of this more as different versions and equivalent versions of the same expression. For the next one, we've got secant t over cosecant t. And if you check your reference, you can see that secant is 1 over cosine and cosecant is 1 over sine. So let's replace these. 1 over cosine over 1 over sine. So dividing by a fraction, this is a complex fraction that you may have seen in 150 if you took 150. Dividing by a fraction is the same as multiplying by its reciprocal. So we're going to flip that 1 over sine t to be sine t over 1. Now the sine and cosine in this example don't cross out, so we're just going to multiply straight across. 1 times sine over cosine times 1. And if we check our references, we can see that sine over cosine is equivalent to tangent. We have simplified this expression. For the next example, anytime you see a squared, that's a really good clue that you need factoring. You can also tell you need factoring if you see two terms separated by a plus sign, and they each contain a sine, or they each contain a cosine. Now, because this has a third term that does not contain a sine, we can tell that's not the type of factoring. But if you've got multiple terms and they all contain sine or they all contain cosine, that's another good clue that you want to factor. So a squared is a good hint that factoring is needed. So let's think about this in terms of x squared, like we used to see when we were still doing algebra. How would you factor x squared plus 2x plus 1? Well, x squared is x times x, and the only way to get 1 is to have 1 times 1. Luckily for us, 1 plus 1 adds up to 2. The difference is that this expression wasn't x squared, it was sine squared. So instead of x, we're going to replace with sine. And our denominator was sine x plus 1. So one of these factors cancels. And our simplified expression for example 3 is sine x plus 1. All right, moving down. We're going to introduce the Pythagorean identities in the next video.